Here we're going to find all the real zeros of a polynomial. The polynomial that we're given is x cubed plus 4x squared plus 3x minus 2. Since its leading coefficient is 1, the rational zeros theorem would tell us that the rational candidates are plus or minus 1 and plus or minus 2. Let's look at the polynomial on the graphing calculator. I've already entered it into the y equals screen. Let's graph it in the standard window. And this is what we see. It appears as if there is a 0 between 0 and 1 that is not showing up on the original graph here in this view. So let's use our window settings to get a little sharper image. Let's use maybe -3 to 3 and -3 to 3. So -3 to 3 for both the x and y axes. I'm still wondering what is happening over on the negative x-axis. I'm going to make the y-min and y-max smaller. -1 and 1 may give us a better look. Yes, in fact, there are two different zeros over on the negative x-axis. Right now, I've got the setting set between -1 and 1, I believe, on the x-axis. No, -3 and 3 on the x-axis. And so it is appearing that there may be a rational zero at, I think, -2. Let's look at that again. I think the other two zeros are irrational, but still real zeros. So let's look at using synthetic division and using -2 as our divisor. So the coefficients are 1, 4, 3, and -2. One will be the leading coefficient in the quotient. 1 times -2 is -2, add 4 is 2, times -2 is -4, add 3 is -1, times -2 is 2, and so the remainder is 0. And in fact, -2 is one of our real zeros. So we can put -2 in that list. Now, looking back at the zeros that are showing on this graph, I don't think that any of the other rational zeros actually are zeros in this case. So that would say that we should look at the quadratic equation that we have here. -1 is the x to the 0 term, 2 is the coefficient of x to the first, and 1 is the coefficient of x squared. So a is 1, b is 2, c is -1. If we use the quadratic formula on the polynomial x squared plus 2x minus 1. So the zeros here would be the opposite of b, which is -2 plus or minus the square root of -2 squared minus 4ac all over 2a. So -2 plus or minus square root of 4 plus 4 over 2. -2 plus or minus square root of 8 over 2. -2 plus or minus square root of 4 times square root of 2 is the square root of 8. Square root of 4 is 2. We're left with a square root of 2 all over 2. So we can factor out a 2 in the numerator to get -1 plus or minus square root 2 all over 2. The 2's cancel. So we're getting the irrational zeros plus or minus, -1 plus or minus the square root of 2. So the other two irrational zeros are -1 plus or minus the square root of 2. These are all real zeros. They all result in an x-intercept for the graph.